Hey everyone, let's look at number 12 in 10.3. We're going to determine the convergence or divergence of this series. And again, yours might look a little different than this, but probably very similar using any method. And so, when I'm looking at this, it's very close. Look for large values of n, this thing that we're, the sequence of terms that we're adding up, it's very close to this, right? For large values of n, 8 to the n will dominate the two, be much, much bigger than it. And so basically we can compare it to that. Now, of course, 7 to the n divided by 8 to the n can be written this way. And that corresponding series, if we look at that, we know that's a geometric series, right? Because it's 7/8, 7/8 squared, 7/8 cubed, and so on. So we're just multiplying by 7/8. And since the value of r is less than 1, then we know it's a convergent geometric series, less than 1 in absolute value. The problem is using direct comparison is we would need an inequality of less than or equal to show that our corresponding series also converges. And the problem is the numerators are the same here, but the denominator here is always 2 less than here because this is a smaller denominator. This one is actually over here greater than this one. So we have the inequality in the incorrect direction. So what are we going to do? Well, instead of direct comparison, we'll use limit comparison. Let's take the limit as n goes to infinity of the a sub n's, which will be the terms of the sequence we're adding up in our series, to b sub n, right, which will just be this. Well, I'll write it in that format here, 7 to the n divided by a to the n, which come from a convergent geometric series. Okay, so let's take the limit as n goes to infinity of this. So dividing by 7 to the n over 8 to the n is the same as multiplying by the reciprocal. Notice these 7 to the n's here will cancel, and I'll have 8 to the n over 8 to the n minus 2. Now this limit, some of you know already what it's going to, but if I divide by 8 to the n in the numerator and the denominator, I just get 1. 8 to the n divided by 8 to the n is 1, and 2 divided by 8 to the n is 2 divided by 8 to the n. But as n goes to infinity, clearly this fraction is going to 0, and so we get 1 as this limit. Now this limit is greater than 0. Why is that significant? Because for the limit comparison test, if the ratio here that we're looking at, if this limit is a finite and positive number, then both series will converge or both series will diverge. So since this is greater than 1, and we know our comparing series is convergent, by limit comparison, our series converges. And so in Achieve, they have this, and this is what we want. The limit L as, this should be N, sorry, not X. N goes to infinity. A sub n over B sub n is greater than 0. Again, where A sub n was this sequence, the ones that we're adding up, and B sub n is the one we're comparing it to. And by limit comparison test, the series converges. Okay, hope this makes sense.